So I'm going to have a go at Leetcode's reverse integer problem. So given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes a value to go outside the signed 32-bit integer range, then return 0. Assume the environment does not allow you to store 64-bit integers. So if we're given 1, 2, 3, we need to reverse it and return 3, 2, 1. Minus 1, 2, 3, we return minus 3, 2, 1. And 120, we return 21, which is just that reverse there. The constraints are that x is a 32-bit integer. So let's have a go at that. Okay, so I'll put in the 3 examples that we were given. So what I'm going to do is make a new integer result. I'm not going to worry about overflowing for now. I'm just going to do the basic job, and then I'll worry about overflowing at the end. So I'm going to say int result equals 0, and while x is greater than 0, I want to add to the result x mod 10, so the remainder of dividing x by 10. In fact, I want to say and then x divided by 10, and then result equals result multiplied by 10 plus x mod 10, and then return result. I think that's basically how to do it. So we multiply result by 10 to move on to the next digit. It starts off as 0, so that won't do anything, but then we add the remainder of dividing x by 10. So in the case of 1, 2, 3, we would add 3 to result. We then divide x by 10, so then that would be 12. We go around again, add 2 to the result, divide x again, so now it's 1, and then we would add 1 to the result, then x would be 0. X is not equal to 0 because we may be negative, and when x is 0 we break out of the result. So I'm going to run that with the 3 test cases and see if it works. 3, 2, 1, minus 3, 2, 1, and 12. So that's what we wanted. So now I just need to worry about the overflow. So I'm going to make a very big number. Okay, so that, because it's an error, it's now higher than the 32-bit integer range. So I'm going to knock one off it, and I'll put some digits in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So that reversed would be 987654321, and that should work. 987654321. But if I set this to a 9, then that's going to overflow, and we're just going to get a random number back. Well, not random, but it's not going to be 99876544321 that we want. So there. So to deal with this, I think what I'm going to do is, what do we need to do if we overflow? If reversing causes a value to go outside the signed 32-bit range, then return 0. So what I'm going to do, I'm going to say int new result is result times 10 plus x mod 10, and I'm going to say if new result minus x mod 10 divided by 10 is not equal to result. In other words, I'm undoing the calculation there. So there I've multiplied by 10 and added the digit. Here I'm subtracting the digit and dividing by 10. And if it's not the original result, because that divided by 10 minus the digit is not going to go back to the result. So if that happens, then return 0. So now we should return 0. Oh, it's return 0 on everything. I do need to say at the bottom, result equals new result. Yeah, that it wasn't catching that. It was just that we were never setting result. So 3 to 1 minus 3 to 1, 12 and 0. So I think that's my solution. I'm going to submit that. The reason I didn't do something like, say, the reason I didn't look at the number, I was told I couldn't store anything larger than a 32-bit integer. So I didn't want to say if result times 10 plus that is greater than integer max value, because the result of that calculation would have to be longer than 32-bit. So that's my solution. Let's submit it and see how it does. Are there any corner cases? What if we give it 0? 0 would just work. I think that's it. Does it pass the test case? It's going to pass the test cases, yeah. And submit. Okay, 1 millisecond, so it's not the fastest, because there probably was a smarter way to check for the overflow, but I'm happy with that. So thanks for watching.